When I made my videos about LoRaWAN, some viewers asked if it would replace conventional Wi-Fi with a much bigger range. Unfortunately, this was not the case because LoRa has a huge range but a minimal throughput. It seems somebody listened to them and invented Wi-Fi on the same frequency band as LoRaWAN using Wi-Fi protocols. Cool! In this video we will check it out to see if it can keep its promises, like going through walls and having a more than 1 kilometer range. We will compare it to standard Wi-Fi and learn that we must pay attention to staying legal. Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. Conventional Wi-Fi uses 2.4 or even 5.8 GHz for transmission. Higher frequencies offer more bandwidth, but they behave more and more like light. That means that they work on a line of sight. We know quite well that 5.8 GHz Wi-Fi does not like walls because our smartphones can lose connection when we move to other rooms. 2.4 GHz is better in this respect. In addition, the higher the frequency, the more it gets weakened as it travels a distance. This is why sub-gigahertz bands can be interesting for many applications. In rural areas, for example, our smartphones often communicate at 700 to 900 MHz because the next tower is far away, while they go up to 3.6 GHz in cities for shorter distances and higher bandwidth. Depending on the country, LoRaWAN uses frequencies around 868 or 915 MHz. This is less than half of 2.4 GHz and is one reason for its wide range and its capability to go through walls. In 2016, IEEE defined a new standard, 802.11ah, for sub-gigahertz bands called HaLow for IoT. Here is what it should do. Until recently, no devices at reasonable prices were available. But now, a viewer found these Wi-Fi extenders. In addition, a similar type that connects two Ethernet cables is available. Both are in the $60 range for two devices. Alpha sells such devices too, but at a commercial price point. And maybe you will see other companies joining the bandwagon soon. I decided on this one because of its ease of use. You plug the base into your home network using an RJ45 connector and power it through a USB plug. The remote station only needs 5 volt from a power bank or from your laptop. All 3 LEDs are on shortly after powering the devices, a sign that they are connected. If you search for Wi-Fi on your laptop, you see a new access point with a name starting with AH Wi-Fi. Please change its default password as soon as possible using your smartphone. 1, 2, 3, 4, 5, 6, 7, 8 is not very secure. You can find the description of how to do it in the product listing. Otherwise, your home network is exposed to everybody with the same device. But be aware, it only uses WPA-PSK, a relatively old and insecure encryption. After that, the remote device's access point is transparently connected to my home network, and my laptop gets a normal address in the typical range of 192.168.0. So it is extremely simple to use, and we are ready for a test. But wait! Because this is a new technology, I had to check if it is legal in Switzerland and if my devices comply with the rules. I suggest you do the same. In most countries, the government or local authorities regulate the use of bands or devices. It is important to ensure that you are not violating any laws or regulations when using these devices. Why was I skeptical? First, if you watch other European YouTube channels, they brag about the high data rates of their HaLow devices. And second, the specification on AliExpress say bandwidth 8 MHz, maximum data rate 16 megabits, and most importantly, 20 dBm power output on 902 to 928 MHz. All of them are okay in the US, but highly illegal in Europe. Unfortunately, these guys did not know they purchased US devices. I hope they did not get a visit from men with dark sunglasses, because the 900 MHz band was sold for millions of euros to mobile phone operators, and they monitor their valuable frequencies to avoid interference. So let's open one of the boxes and see if we find an antenna connected to do some measurements. At the remote station we see two antennas plus a tiny board. One antenna is connected to Wi-Fi, so the other must be in the 860 to 870 MHz range if we are lucky. If not, we know at least and can start a dispute on AliExpress. Here you see its signal on a spectrum analyzer. It is 4 MHz wide and has a maximum power of roughly 14 dBm or 25 mW, which are legal values for Europe. According to my information, these 4 MHz are two channels of 2 MHz, but they are somehow used in parallel. So my trick at order time worked. I chose the color EU and wrote a short notice to the supplier. It also does not emit visible harmonics, by the way. The packaging and both devices were unmarked, and no manual or technical description other than the marketing material on AliExpress was supplied. There is also no CE sign, which is illegal in Europe. So, how can you check you got the right version? Because the US version is much more powerful and offers a bigger bandwidth, you go to your basement to not disturb anybody, place both devices close together, switch them on, and check your internet speed with the laptop connected to the remote device. If it is above 10 megabit per second, you have the US version. If it is around 4 megabit per second, yours most probably is the European version. Of course, only if your home internet speed is higher than 10 megabit per second. Are we ready for the test now? Not yet. I want a 2.4 GHz for indoors and outdoors and a 5.8 GHz outdoors link for comparison. For the outside tests, I use these cheap and small MikroTik directional antennas. Keep in mind that these devices are not only antennas, they contain a transceiver and, in addition, a full-blown router. According to MikroTik's comparison, we should get 54 megabit per second over a distance of 3 kilometers for 2.4 and 5.8 GHz. Not bad if we want to believe it. And I will use the HAP AC3 with its omnidirectional antenna for comparison. For the indoor tests, I connect this cheap 2.4 GHz router with the HAP3 on the roof. You might ask yourself how and why I choose these devices. The 860 MHz devices are the obvious choice. They use omnidirectional antennas. For the outdoor tests on the other frequencies, I choose directional antennas. Why? Unfortunately, we are not allowed to change antennas on any devices in the ISM bands. So currently, there are no legal directional antennas for the HaLow devices. For 2.4 or 5.8 GHz, you get routers with directional and omnidirectional antennas. Because in outdoor scenarios, you usually know where your stations are, directional antennas are perfect. Because of their narrow beam, they do not disturb others and offer better performance. Indoors, however, Your end devices usually move and omnidirectional antennas are the better solution. Let's start the test. I place the HaLow router, the HaLow base and 2 directional antennas on my roof. The rest comes with me to 2 different places. Indoors, I do not test 5.8 GHz because we already know that the results will be worse than with 2.4 GHz. The tests will be simple. First, do I get a connection? Easy with the sub-gigahertz devices because they have a link LED. For the other devices, I use pinggoogle.com. And second, to determine the transfer speed, I connect to a nearby internet speed test. Because my internet speed at home is 600 megabit per second, the limiting factor will be the connection under test. I start at my preferred first location, roughly 100 meters from my home, to check if everything works. If not, I can return to home to fix it. Everything works, and here are the results. The next place is nearly 1.4 kilometers away in a line of sight, and here are the results. 860 MHz is still working. 2.4 GHz was very unstable, and 5.8 GHz with 2 directional antennas was pretty fast. However, 5.8 GHz with the omnidirectional antenna on the HaLow router and the directional antenna with me was also not working. I got a connection, but the speed was too low for a test. I was surprised by the 2.4 GHz bad performance, and I do not know why it did not work. Its output power is higher than that of the 5.8 GHz antenna. Of course, because the antennas are similar in size, the 2.4 GHz one has less gain. Maybe I could have tampered with a lower bandwidth, but I wanted to stay with standard settings. HaLow kept the promise and delivered over a distance of more than 1 kilometer. I quickly tried a bit below 1 kilometer, but the speed was not higher. In tests 3, 4 and 5, I will challenge HaLow's through walls claim. Keep in mind, in Switzerland we have small houses, but we build them for eternity. So they contain a ton of structural steel. In other countries this might differ, as might the range for the different devices. As said before, I use the HaLow router and the HaLow base on the roof. Test 3 is 1 floor below the roof. Here are the results. Test number 4 is 2 floors below the roof, in the middle of the house. HaLow and 2.4 GHz still work. Test number 5 is in the basement. Only HaLow works at a reduced speed. The outdoor tests show that sub-gigahertz has an advantage over 2.4 GHz, but has no chance against 5.8 GHz. Maybe if we could get devices with directional antennas, we could extend the HaLow range. But keep in mind, lower frequencies also mean bigger antennas. So outdoors, my choice is 5.8 GHz, because of the bigger bandwidth. A quick scan shows that 5.8 GHz is pretty crowded where I live. Directional antennas help for sure to overcome this issue. Indoors, HaLow definitely has a range advantage, but at the cost of lower maximum speed. If you want to connect hidden IoT devices without adding access points, HaLow definitely is a good choice. In all other cases, 2.4 or 5.8 GHz is better. And what about power consumption? The 4.4 GHz router consumes 150 mA, the HaLow base 122 mA and the second HaLow station 80 mA, about half of the 2.4 GHz router. Keep in mind that you get 2.4 GHz dongles with similar or less power consumption. Summarized, I like the ease of use of the HaLow devices. Because no standard Wi-Fi was available outside my house, I used it to connect low-speed devices for my RTK GPS tests in the last video. Inside the house, I have access points on every floor, so I have good 2.4 and 5.8 GHz coverage and no need for HaLow. I also created a few VLANs with different SSIDs for guests and other important things. This would not be possible using the HaLow devices at hand. If I needed an outdoor link, I would go with 5.8 GHz antennas because they have a small beam and MikroTik routers offer WPA2 encryption against hacking. I know of companies that conduct some trials using HaLow instead of LoRa for critical situations because of its higher throughput. We will see if they will succeed. It is probably a good choice for ad hoc situations like holidays or on the road because its flexibility and ease of deployment. And I read that sub-gigahertz waves travel much better over water, at least from a ship to an island. What would I expect if I used the US version? For sure higher data rates and maybe also a longer range, but not much because the broader bandwidth will eat most of the extra power. And if you are a ham radio operator, you can add bigger antennas. The band above 900 MHz is open. Not so with 860 in Europe. So HaLow is a better choice in the US than in other countries. This was all for today. As always, you find all the relevant links in the description. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. Thank you. Bye.